This is the formula for integration by parts, and what we're given initially is an integral with a product of u and dv. And so what we can do here to find our final version of the product is we can take u and we can differentiate down to find the derivative of u, and then we can take dv and then we can integrate that to solve for v. And then what we do is we go across here, u dv, to get this value here, and then we can go diagonally down from v down to du to get what goes inside the integral. So as long as you just follow that simple 7 method after you make your u, du, dv, v legend, you should be able to come up with your integral from integration by parts on this side quite simply. So now that we've done the simple mapping out of the formula, let's look at a problem that may well show up on the final exam. So we have the integral of the product of x times e to the pi x dx. And what we do first here is we make our map. We start with u, du, dv, and v. And so it's important to kind of pick which one you'd like to use. And I think that I'd like to use x for my u. And then, of course, the derivative of x is simply dx. And then our dv here will be e pi x, which we can integrate up to v. And when you integrate this, remember, you take this number here and you pop it on the bottom. So what you get then is e pi x over pi. That's the integral of e to the pi x. And so now, following our pattern from earlier, we can go across u to v, and we'll do x e pi x over pi minus the integral of diagonal here from v down to du. And we're going to pull this here, this pi, go ahead and pull that out front. So we'll put 1 over pi out front. So then we just have the integral of e to the pi x and then dx. Next, we just follow this down. X e to the pi x over pi minus 1 over pi times, and the integral of e to the pi x we've already done. It's right here. That happens quite often with integration by parts. So we'll just pop this integral in here. We'll say e to the pi x over pi. And then since this is a integral with no bounds, we're going to add a plus c. Add that constant at the end there. So then just to solve this, we'll say x e to the pi x over pi minus e to the pi x over pi squared plus c. And that is the solution to this integral. It's very important to try and think of some integrals like this where they have some characters like this pi x up here in the exponent of the e, that you may not navigate in a traditional study session, because it's questions like these that professors will ask because they will think that you may have missed that while studying and revising, and they'll try and trip you up with that. So as long as you remember how to navigate special instances like that, you should be okay. Okay, and let's move on to our next integration by parts question. We've got x squared ln x dx. Now, as per usual, anytime you see a natural logarithm within your product of your integrand, go ahead and use that as u. You'll have a very tough time using that as your dv value because it's quite a bit harder to integrate a natural log. It's actually necessary to integrate a natural log through another integration by parts. So if you just let that be u, like so, u equals ln x, du, we easily know how to differentiate that as 1 over x. We'll let our dv equal x squared, therefore our v is x cubed over 3, simply integrating that. And now we'll follow our pattern. We'll go across u to v, and we'll say 1/3, or you could just put the whole thing over 3, whatever, x cubed ln x minus the integral from v down to du. So we'll go ahead and pull this 3 out again, pull that out front like this, 1/3, and then x cubed over x is actually just x squared dx. And so now we need to simplify, and I think I will just go ahead and put all of this over that 3. So we'll say x3 ln x over 3 just to make it a little bit cleaner. And then we'll say minus 1/3. And again, we have x squared and x squared. We've already integrated that. It's very easy. So now we can just say x cubed over 3 plus c, because again, this is an indefinite integral. There are no bounds. And so now to get the final solution, it's just x cubed ln x over 3 minus x cubed over 9 plus c. And that is the solution. I hope this video helped. If you have any other questions with integration by parts or any other calculus related things, please feel free to write it in the comments and I will be sure to make a video about it.